we are going to get into the topic today of what's known as slope intercept form. And what we're really talking about is the equation of a line. Because lines that we're graphing now in two dimensions have both an x and a y in them, we talked about that a line is a system of points, and all those points have x's and y's, so any equation for a line is also going to have x and y in the same equation. And the question is, can we get y by itself in an equation? For example, if I gave you this problem, if this would have been, say, x plus 6, if I can make it 6, I think everybody knows how to solve it pretty quickly. We just subtract 6 from both sides and we'd be home free. But let's take the case where it's a y. And we're problem solving, we're trying to get a variable by itself. We're trying to get, in this case, y by itself. So let's just subtract an x. And now we have y equals negative x plus 3. You've already converted into slope-intercept form. That's it. We are getting y by itself. Another example would be 4x plus 2y equals 8. Well, if we want to get y by itself, we would start by subtracting 4x. And then remember, 4x and 8 are not like terms, so we can't combine them by any means. And then to get y by itself, we've got to divide by 2. And when you have multiple things in an equation, every one of the terms is going to have to be divided by the 2. So negative 4 divided by 2 is negative 2. X comes along for the ride. Plus 4. You're in slope-intercept form. 1/2 y minus 3 is equal to x. This one's a little different. The x is already over there, but we'll start by adding the 3 to both sides. And then multiplying, whoops, forgot my y. Multiplying everything by 2, so we'd have y equals 2x plus 6. Okay, so as you notice, the form we're always in is y equals something x plus a number. What we're really in is y equals mx plus b, where m, from what we know before, is equal to the slope of a line, and b is actually its y-intercept, meaning where the line crosses the x-axis. So if you follow me here, previously we had 2 points and we were able to graph a line. We just connected the points. But now that we know about slope, if we have just one point, in this case the y-intercept, and we know slope, we can use that to find a second point. Got 2 points, you're ready to work. So you can graph a line once you get it into slope-intercept form. And let me show you how you do that. Y equals 2x plus 1. So when you get a problem like this, ask yourself, is it in slope-intercept form? In this case it is. So we know that m is equal to 2, but slope is always in a form of a fraction, so we're going to make that 2 over 1. And the y-intercept b is equal to 1. So on a Cartesian coordinate plane, we always remember that x is horizontal and y is vertical. We're going to graph first the y-intercept. That's b. So a y value of 1. So that point is on our line. But what we don't know right now is, our line go like this? Does it go like this? Does it go like this? We won't know that until we actually use the slope to find a second point. Well, if slope is 2 over 1, we're going to go up 2, because that's how much we rise. Remember, the definition of slope is rise over run. And run 1, that means that must be another point on our line. Connect the 2 points, and you've graphed your line. Not too bad. Not too bad. Take a couple more examples. Y equals 1/2 x minus 3. So again, m is 1/2, b is negative 3. So we're going to go to negative 3 for y-intercept. Remember, this is y and this is x. And then slope is 1/2. That means we go up 1, but then 2 to the right. So there's our other point. And we catch those guys graphing. Graph the line. And let's do one with has a negative slope. Y equals negative 3x minus 2, which means slope is negative. Remember, we're going to write it as a fraction, so rise over run. And b is negative 2. So in this case, we go to negative 2. There's 1 point on the line. And then I'm going to have to go up 3 over 1, but this time, because it's negative, I'm going to go 1 to the left. And that's how I want you to think about it when you graph. That you always rise from your y-intercept, run to the right if it's positive slope, run to the left if it's negative slope. And you can see from the previous examples, positive slope, line rises left to right. Positive slope, line rises from left to right. And then negative slope, line falls from left to right. And then tying it all together goes back to the beginning of this example. What if you're given a line and it's not in slope-intercept form? Well, we put everything we learned today in one thing. If we subtract 2x from both sides, we'll now have y equals negative 2x plus 3. So that means the slope is negative 2 over 1. The y-intercept is 3. Pull up a Cartesian coordinate plane. Y-intercept is 3. Slope is up 2. But we're going 1 to the left because the slope is negative. Always rise. Run right for positive, run left for negative. And connect the dots as best you can. Lines falling from left to right, we look good. That's a check you can always make to make sure that you're doing it correctly, is if the line you graphed, if it does have positive slope, it needs to be rising from left to right. So try this guy. We're going to add 4x to both sides, so negative y equals 4x plus 5. We don't want to solve for negative y, we want to solve for positive y. So we have to multiply everything by a negative 1. So now we've got a slope of negative 4 over 1 and a y-intercept of negative 5. So 1, 2, 3, 4, 5 y-intercepts. Slope negative 4. Up 1, 2, 3, 4, and run 1 to the left. And connect the two dots. And we've got our line. Last one. 3x plus 6y is equal to 18. Same sort of deal. We're trying to get y by itself. Divide by 6. Well, negative 3/6 is the same as negative 1/2, and 18 divided by 6 is 3. So I've got a slope of negative 1/2 and a y-intercept of positive 3, and that looks like one, 2, 3, y-intercept, up 1 and over 2 to the left because it's negative. Connect the dots, and just by knowing that much information, you can now graph lines. Okay.